So yeah, hi. Thanks for coming. How are you all? Good. Excellent. So just before I start, this talk is called Infrastructure as Code with Terraform and Azure. So before I start, who's using Azure out of interest? Okay, so most of the room. Cool. Who's heard of Terraform before? Cool. And who's using Terraform? Also cool. Yeah, I'm Tom. I'm primarily working on the Azure provider. I've been working at HashiCorp for a couple of years, or just coming up to a couple of years now, primarily on the Azure provider, but also some others. We've got quite a presence in Europe now, but yeah. So, HashiCorp have a suite of products you may have heard of: Vagrant, Packer, Terraform, Vault, Nomad, and Console. They cover the application lifecycle. This talk's on Terraform, and specifically Terraform and Azure. But all of this should be applicable to any provider too. So just to kick off, I just want to cover what infrastructure as code is, just to get us all on the same page. So infrastructure as code allows you to declaratively describe your infrastructure as code, such as reproducible at any point in time. This means you can apply standard software development techniques to it, like CI/CD, or code review, CI, and CD if you want, which, yeah, helps. Side benefits is this allows you to migrate to different regions as you need to, and that your infrastructure is documented, and yeah, ensures that your infrastructure meets any policy requirements as well. This last one's particularly fun, so particularly useful, sorry. Yeah, in terms of cloud automation, there's other technologies out there. On templates, there's obviously the one for Azure, there's CloudFormation for AWS, Deployment Manager for Google, et cetera, et cetera. So yeah. So let's talk about infrastructure as code with Terraform. So yeah. So Terraform uses DSL that's known as HCL, which is the HashiCorp configuration language, which is kind of JSON-like. So let's just take a look at some HCL so we can have a look. So this is some HCL which deploys a resource group into the UK South location, and then creates a virtual network inside of that resource group. We're going to come back and break this down in a moment, but what we're able to do is thread variables through from one resource to the other, which means that we can deploy the location once, or the resource group and the location once, and then thread them through. What's really nice is HCL provides a common language which can be used to provision just about anything on any provider, or any cloud, or anything at this point. But that kind of raises the question of what's a provider? So in Terraform land, we have 80 official providers at this point. It's quite a big list, but there's over 80 HashiCorp providers, there's 80 community providers, and people have their own. I just want to call out a few. So we have like all the big clouds in here, AWS, Azure, Google, et cetera. We have DNS providers, we have SaaS services, and you can also run stuff on-prem too. But the nice thing is you're able to mix and match these as you want, to be able to say, deploy my infrastructure to Azure, and then configure my DNS in DIN or whatever else you're doing. So you can tie things together in a really nice manner. And as I mentioned, people are building their own community providers. So if you have an internal provisioning system, you can write a provider for Terraform that allows you to use that one language to provision on that too, which is really nice. So basically, if there's a CRUD API available, create, read, update, delete, then you can build a provider for it. So let's go back and look at a Terraform resource. So this is a snippet of what I showed earlier. This provisions a resource group in Azure. But let's break this down a bit. So the first word on here is resource, which is like a type of thing that Terraform supports. So there's two of these, which is a resource and a data source. So a resource provisions something, and a data source retrieves information about it in like a read-only manner. We'll come back to that later. But next up is the name of the resource. So in this case, we're provisioning a resource group. So the way this is structured is the name of the provider, so Azure RM in this case, and then what it is, so a resource group or virtual network or whatever else it is. Next up is like a friendly identifier for this resource. This is just a Terraform internal name. So if you're building like a module, which we'll come to later, you might have like a front end and a back end subnet or whatever you're doing. Yeah. And then finally, we have the properties within the block. So in this case, the name, the location. But optional property, like these are just the required fields. There are some optional properties which, if they're not omitted, are obviously not set. Yeah. So this is what a resource looks like in Terraform. But how do we go from this to actually provisioning the resource group? So Terraform itself is a command line application, so we can just download the binary and run Terraform on the command line, and it'll, by default, show us what commands are available. The four I want to call out are init, plan, apply, and destroy. And we're going to run through them in turn. There's a bunch more, but these are the interesting ones. Or the common ones, I should say. So what Terraform init does is to basically look at all the code you've got in your working directory and then download the relevant providers. So Terraform is modular insofar as we have this core that determines, that can speak to any provider, and then each provider is a separate binary, which means you can use any version of anything you want. So when you run Terraform init, it'll look at the directory you've got and say, hey, I'm using the Azure provider. And so what I'm going to do is to go download that binary locally. Yeah. Next up is Terraform plan. And what this does is to look at the state in our local directory, to look at the state in Azure, and go, hey, what do I need to do to get from what's in Azure to what should be as is defined locally? So if we run Terraform plan, what that's going to do, because this resource group doesn't exist, it's going to go and try and provision that. Yeah, or it's going to suggest provisioning that. And say at the bottom, 1 to add, 0 to destroy. You can optionally output this plan to a file too. And what this means is that you as a developer may not necessarily have permissions to apply in production or in this region or whatever it is. So you can pass that plan file to someone else who may. In a, hypothetical scenario. Next one up is Terraform apply. And what this does is to determine what changes need to be made, again, via the plan, and then make those changes. So in this case, again, it's going to do a plan for us because we haven't passed in a plan file, and then say, hey, do you want to make these changes? Is this okay? What's really nice about Terraform's plan and the plan you get in the apply is it's going to say, I am going to do these exact things, and in particular, I'm going to destroy this. Is that okay if it needs to destroy something? Which is kind of cool. So yeah, and if you type yes, it'll then go ahead and do those changes. So in this case, this will provision a resource group. One really nice thing about Terraform is because of the interpolation, because of the references between resources I showed earlier, Terraform knows what it can provision in parallel. And so we're able to, for instance, like a resource group, we can provision first, and if you've got network and 2 subnets, we can provision the network and then the subnets in parallel, which means Terraform will provision as fast as it can. Yeah. So once we've done Terraform plan, once we've applied those changes, we can then run Terraform plan, and what that's going to do is, again, to check the state locally with the state in Azure and diff those. And in this case, because we've applied those changes, there should be nothing to do. Yeah. One thing that's particularly cool is because we're reaching out to Azure and actually checking the state of the resource, we can check if that's changed remotely. So if someone's added a tag, and there shouldn't be a tag, Terraform will say, hey, that shouldn't be there, and prompt to remove that tag, which is kind of cool. And then the final thing I want to call out is Terraform destroy, which you may not necessarily want to run on production, but maybe you're into chaos, I don't know. But it's actually a really handy way of tearing down an environment. So I know companies who spin up their entire infrastructure, their entire staging environment at 6 a.m. and they tear it down at 7 p.m. when everyone's gone home, which is a nice way to do it. But yeah, it's way nicer than going to the portal and deleting stuff or random scripts which do it. And again, because this is a destructive change, or because this is going to make changes, it's going to say, hey, here's what I want to do. Is that okay? In this case, it'll destroy the resource group, which is fine. Yeah. Any questions up to this point?
You mentioned do you like chaos? So are you saying not to use destroy in production?
No.
Delete the resource?
No, I mean, Terraform Destroy will destroy all the resources. So if you want to take down the whole of production, then sure. You can destroy a single resource, like if you need to tear down an app service or something. But yeah. Cool. So next thing we're going to do is to go through and provision a resource group in a virtual network, just to go through that. So, mirror displays. I'm hoping you can all read that. Getting nods, cool. So, if we go to the Terraform website, cool, Zoom works. It's always helpful. We have this providers section, which as I mentioned earlier, we support a bunch of different providers. In here, this is the Azure provider. And yeah, there's sample usage for just about everything in here. So like for a public IP, this is how you provision that. And there's arguments for that as well. An example, like information about the SKUs and that kind of thing. So next up, what we can do, if we look at the documentation for virtual network, what this is going to do is to provision a resource group and then a virtual network. What's quite nice with a virtual network is you can either define the subnets in line, like so, or you can define them as independent resources, which means you can compose them together. So you could have like an ops team create the network, and then teams create their own subnets for whatever they need. And this is possible with a bunch of resources in Azure. So, but yeah, so one of the things we're going to do, if we go, we'll create a resource, and then give it a name. So this is the name of the resource. And an identifier, so in this case, example. But this can be any name we want. You can't variabilize that, but you shouldn't need to. But you can variabilize anything else you want. So a resource group has a name, so hello. Ooh. I can't type apparently. And a location, so it's UK South, right? So if we, oh yeah, one thing I should call out. This provider block at the top. So I mentioned that Terraform is binaries. So we release the Azure provider pretty often. So yeah, we have this changelog on the website of like what we've done. So we did a release yesterday. Cool. With all this stuff in it. But it means you can pin to a specific version of the provider you want to use. So if you don't care about the new shiny things that came out yesterday, then stay on an old version, it's fine. Yeah.
What's the catch-up time compared to the Azure environment? Basically not new types of environment or
New resources?
yeah.
We'll come to that in a bit. Sorry. But yeah, we're getting better, but we'll come to that in a bit. What was I doing? Oh yeah, one. Sorry. So, yeah, I mentioned running stuff frequently. So this is we're releasing like once every couple of weeks-ish. But in this case, I'm pinning to version 119, which we put out yesterday. And the way I do that is to say, this is like, I want to use exactly 119. You can use whatever syntax you want here to say like around 1.x or whatever you want to do. But this means that all your team members or whoever else will pin to that version too. So the first thing we do, 2 seconds, sorry. Ooh. Sorry, meant to do that before the talk. Right, first thing we do is to run Terraform on it. And what that's going to do again is to reach out to the HashiCorp website to go, hey, you want to use version 119 of the Azure provider? Sure, I'd go download that. And that basically sets up the working directory locally. Next thing I can do is to run Terraform plan. Sorry, I should make that bigger. There's this fun bug where if I make my font size too big, my terminal goes invisible. So, yeah, hopefully that's readable. Anyway, so I've run Terraform plan. And what this has done, again, is to check the state locally, to check the state in Azure. And because there's nothing there, it's going to go, hey, I need to like provision that. So next up, if we run Terraform apply and open the portal at the same time, come here. Sorry, if I run Terraform apply, which, what? Ah, this will be the one that disappeared earlier. Okay. Sorry. Azure bash. I use mchain to keep some environment variables. You don't need it. Right. Terraform apply, which is being applied somewhere else. Great. Here? Fine. Anyway, sorry about that. Terraform will lock you. The error I got here actually is Terraform telling me that, hey, you're already running Terraform somewhere else. Like, you can't apply 2 changes at once, which is a good thing. But yes, all that to say, I can run Terraform apply. That's going to go, hey, I know this resource group doesn't exist. Let's create it. It'll go do that. And if we go to the Azure portal, we have a resource group, which is exciting. And it's done that. And we can run Terraform plan. And again, that's going to go compare the state locally with the state in Azure and go, hey, I need to create that resource group. While that's running, just because, yeah, if we add some tags to this, so hello, WinOps. And these are all documented on the website. So if we rerun plan while that's going to go, there's no tags on the resource in Azure, there's a tag locally, I should add it. And if we, if we add a tag in Azure for, let's apply it, why not? And if we add a tag in Azure, so, I don't know, WinOps London, and rerun plan, that's what I wanted to do. So there's a tag in Azure now, there's a tag locally, they'll diff, there'll be a conflict, and Terraform will prompt to override it. Eventually, come on. Cool. Yeah, so Terraform will say there's a tag called WinOps London that I'm trying to remove, and there's a tag called hello locally that should exist. Yeah. And then the same thing applies for networks. So we can go to the network resource and go, hey, I want to define a network. And I know just from working on it that these are the required fields for a network. So an address space, the resource group name, etc. So if we copy paste that, because that's fun, we can update the references. And what we have here is called an interpolation function. So this references from one resource to another, which means you can define these variables once and then reuse them, which is really nice. The other thing it does is it allows Terraform to work out the order in which things should be created, so that Terraform knows that, hey, I need to create the resource group before I create the virtual network, before I create whatever else, which means you can define these however you want. Yeah, so call it whatever you want, doesn't matter. And if I close these two and switch here, if I run Terraform apply, because we didn't update the tags, it'll say I want to update the tags, and also I want to create the virtual network. So you've got one to change, one to apply, one to apply, one to change. It'll go do the resource group first because it's dependent on the network is dependent on it, and then update the net or then create the network. And again, it's used the variables from the resource group. What's quite nice in Terraform is we normalize the location field, so it doesn't matter if someone types West space Europe or West Europe in uppercase or lowercase or whatever. Terraform doesn't care. So you get this nice consistent diff. And again, running plan Should give us nothing. So. Cool. The final thing we can do is Terraform destroy, which, yeah, as I mentioned, will destroy everything Terraform has created. So you may not necessarily want to run that in production, but it's fine. So in this case, it's going to try and destroy the virtual network and the resource group. And again, because Terraform knows that I need to create the resource group before the virtual network, it knows it needs to tear down the virtual network and then the resource group. So this works in both ways. And what's nice about Terraform is it'll keep polling and telling you exactly what it's doing. So in this case, like destroying the virtual network takes 3 seconds, and then destroying a resource group takes a bit for some reason. Yeah, cool. So all that to say, if I go here, do that. Where's my... Okay. So yeah, just to recap, Terraform init downloads and sets up the local working directory. Terraform plan will then determine which changes need to be made. Terraform apply will then make those. And Terraform destroy will destroy anything that Terraform's created. You can scope these as you want to, so you can say like, only create this one change or destroy this one change or whatever. Cool. So Terraform's all well and good, I hear you say, but what about all the existing stuff I've got? Provisioned through on templates or the portal or the CLI or something else. So Terraform has 2 ways of referencing or working with your existing infrastructure. The first is a data source, which allows you to reference information about the resource. So for instance, if you have like a network as an example that's created by someone else, and you want to create a subnet within that, you can get read-only information about the network. So a data source looks very similar to a resource that we saw earlier. The only difference is really this first keyword, the word data, which signifies it's a data source rather than a resource. There's also less fields required for a data source because we're just looking it up, we're not creating it. Yeah. But what's quite nice is we can then output any variable from that or any attribute on it. So in this case, the address space. Yeah. Yeah, hi. Nope. Read only. Yeah, so read only reference to it. So if you've only got like read permissions to it, it's fine, but you might not. Yeah. It also means you can decouple your Terraform code. So you could have like again, like a network team define this stuff centrally in one repo, and you have your stuff decoupled in another, which is kind of nice. It's all right.
So is it looking at a real object in your
Yes.
description?
Yeah, so it'll query based on, in this example, based on the resource group and the name, it'll look up that resource. So it literally just does an HTTP GET to put it down. That's the other nice thing, is like, rather than having the long GUIDs, we have like, yeah, like other fields. So it's a bit, they're still there if you need them, but we don't expose them as much just because like we can use the names instead. Cool. However, the other thing you can do is to Terraform import. And what this will do is to bring the resource under Terraform's control. So we just mentioned about the resource IDs. Terraform import actually uses the resource ID because that's just the way like things are referenced in Azure. So in this case, if you want to import a resource group, use Terraform import resource group.test, subscriptions, whatever, and then the name of it. What this will do is go look up the state of the resource and bring under Terraform's control. So import all the information that's available about it, and then allow you to manage that with Terraform. So if you provision something with the CLI, with whatever else, you can then manage it with Terraform. Yes. Yeah. So like a data source is a read-only representation. Import is when you want to actually like bring it under Terraform's control. On the documentation, on the Terraform website in the documentation, on every resource, every resource in the Azure provider, there's a section about importing, which you can't see. Awesome. Sorry. Please feel free to call me out on that. Yeah, so in this case, there's like this is how you import a network or a Kubernetes cluster or whatever you're using. So everything, to my knowledge, in the Azure provider supports import at this point, which is cool. Yeah. Yeah. Oh, what's going on here? Sorry. So yeah, let me give a demo of that. So I have a pre-existing Kubernetes cluster, or I should have. I accidentally deleted it just before the talk. So I provisioned this through the Azure portal, as you can see. It's apparently done, so, you know, fingers crossed. So we can go connect in the portal and do whatever we're doing. One of the things you get in the portal is to be able to connect to it. I have using existing data sources. Sorry, all of this is in a GitHub repo as well. I'll link to at the end. But in this case, I'm going to skip that one just for time. In this case, I have a data source for the Kubernetes cluster. And what this is going to do, again, is just to look up information about it. So if I go to the docs for that here, Terraform will say, hey, here's all the information I need to look up the data source. And then here's all the information you can get back from that. So for instance, one of the things you can get is the Kubernetes config, which allows you to use that with the Kubernetes provider in Terraform or the kubectl command line, or whatever else you want to use. Yeah. The other nice thing we can do with those credentials is then to thread those through into the Terraform Kubernetes provider. So in this case, I'm passing through get rid of that, sorry, through the host, the username, the client cert, etc. And this allows us to create a namespace in Kubernetes. So, where did I? Yeah. So I have a couple of command lines from the Azure portal. What this is going to do is just configure the credentials locally. Cool. We'll do it live, it's fine. So if we get the credentials for that, and then browse the resource group, that should then open the Kubernetes dashboard for us. Come on. Cool, and we have a Kubernetes instance, that's cool. So again, this is referencing a pre-existing cluster. I'm not managing it at all, or I'm not changing it with Terraform at all. But one of the things I can do, if I run sorry, I got this in folders. If I run Terraform init again, that'll download the provider. Come on. It's always slowest when you're watching it, isn't it? Okay, so because we've got two providers defined, Terraform's gone ahead and downloading both of them. And again, because I've pinned the versions of those I want to use in the provider block, Terraform knows I want exactly that version. So, sorry, 2 seconds. My Azure credentials are set up as environment variables, so I pass them through this way. So, if I run Terraform apply, that's going to go ahead and look up the credentials from the AKS cluster we've just created. I'm hoping I got the names right. Yes. Cool. And go, hey, I'm now going to connect up to Kubernetes with those credentials, see if there's a namespace that exists called WinOps London 2018, which there isn't, and then go create it. So if we hit yes, they'll go create it. And if we refresh, it's there. Very exciting. But the nice thing is that you can combine any providers together you want. So Kubernetes is one example. There's like MySQL. There's like just about anything. There's an example of there was a cloud that launched last year. And I Googled the day after it launched for cloud name Terraform provider, and that like already existed, which is kind of cool.
Real quick question.
Yes, sorry.
With the providers, is it automatically able to import, or is that only certain providers that can import?
It's certain resources. In Azure, we support everything just because like we've done it from the start. AWS is something like, well, it's a percentage. I don't know what a percentage is, but it depends on the provider.
Sphere, for example.
vSphere should. I don't know, but it should for just about every resource. Yeah. Where are we? Mirror. Cool. So if we come back to slides. So yeah, we've provisioned the namespace in Kubernetes, which is exciting and works.
So if you did a destroy on that, it'd only delete that part of.
It'll only destroy the namespace, yeah. It'll leave the AKS cluster kicking around, which is nice, because it means, again, you can have decoupled things. So you provision the AKS cluster in the morning and whatever else after that. So next up is modules. So Terraform's all well and good until you have everything in one file or one folder, and yeah, things can become pretty long if you've got a lot in there. One of the nice things about modules is you can reuse all of that code. So Terraform in module is any directory containing any .tf file. So .tf file is just a Terraform file. What's quite nice is that every example we've seen so far is technically a Terraform module and can be referenced in that manner. A module can have inputs and outputs. It's kind of a self-contained unit, and they can be sourced from the file system, a Git repo, module registry, or whatever else you want. For example, in Azure, you might have like a resource group name or a prefix or a location or something and pass that through. And you can chain modules together how you want to, which is quite nice. So in this case, I'm sourcing a module from a local file system. So similar syntax to before with module and source. You can also specify a Git repo. So in this case, I'm putting a VPC and I'm specifying a Git tag. So there are companies I know who are using Semver internally for Terraform modules, and they have tests for those modules to check they're in a given format. But it means that developers can pin to whatever the latest tag they want is, which is kind of nice. And you can also use a module registry. So we have a public module registry. There's a few of these available. We have a public one called the Terraform Module Registry. We have a private one. People have written their own. It's just an API. But the mirror displays. The nice thing about this is you can search for, like, go for Azure, for instance. And there's a bunch of modules here. Verified are, like, signed by us. And then there's, like, other ones which aren't. But you can publish your own modules however you want. So in this case, creating a Service Fabric dev environment. I've not used this, just Googling it, which gives you information on how it works. So if you have something kind of complex or like unique to your organization, you can create modules that do whatever you want, which is kind of cool. And I need to mirror my screen, sorry. Thank you. That's fine. Okay, I'm going to give you a quick demo of that. I'm not going to provision it because it's spinning up a VM, which takes a while. So the way Terraform modules work, and this is all in the repo that I'll share with you, or that's public actually. So what I have here is a locals block, and these are basically local variables. So I can define like private variables in any kind of programming language, and there's the variables which are separate. So these are basically exposed publicly. So in this case, I have defaults for those, and you can specify descriptions or whatever you want. So in this case, I have a prefix and a tag as a variable, and I then have I'm creating a resource group here, using those variables, and then threading those through to the modules. So in this case, I'm creating a virtual network, which combines all the stuff it needs to, which is on disk. So in this case, virtual network, which creates a virtual network, subnets, 3 subnets, and then outputs those. So an output in Terraform is, well, yeah, an output. And then what I'm doing is then threading those variables through to this other module. So in this case, I'm putting the virtual machine that's provisioned into the backend subnet. You can thread anything anywhere you want, which is kind of nice. The other thing I'm doing is to thread the tags through. So what this means is I can define the tags once locally. So for instance, here I can do default, hello, world, and that'll ensure that all the resources in this have those tags. It's just a variable, so it's just threaded through. Yeah. As I mentioned, you can source these from anywhere you want. There are teams who do this with like semantic versioning and Git tags. And yeah. All of this is on GitHub, so I will link to that in a bit. Cool. So, apologies, I can't demo that time. So, next question is what's supported. So this came up earlier. So I've been working at HashiCorp for a while. I get, like, does Terraform support X quite a lot? So I figured it's worth taking a minute to talk about that. So over the last couple of years, we've been working quite hard to add support for things. At this point, Terraform supports, I would say, most of the core workflows you're looking for. We've gone from 48 resources when I started a couple of years ago to 175 today. I just want to call out a few of these. So we have like IaaS, so app gateways, virtual machines, networks, etc. We have all the PaaS services, so AKS, web apps, etc. Or app services, sorry. We have the hosted services too, so MySQL, etc. And again, what's nice is you can combine these. You can provision your MySQL database with Terraform in Azure, and then use the MySQL provider to create a table within that if you wanted. Yeah. The other thing that's kind of unique to Terraform is that we have some resources that don't exist elsewhere. So one I wanted to call out was the storage blob. So you can upload a file from within Terraform to an Azure storage blob, which means, or to Azure blob storage, sorry, which means that, yeah, you can have all this run in a single run. So you can upload your artifacts, deploy that to whatever you need to from there. So for instance, the function app can be done from within Terraform. We've also split out a couple of resources. So logic apps are traditionally quite complex. It's basically one big JSON document inside of another JSON document. We split this out into different resources, and same for load balancers too. What's quite nice is you're able to say there's some meta parameters you can use in Terraform for things like count to say I want to create a virtual machine, but actually I want to create 5 of these, or 10 of these, or whatever you want to do. So by splitting this out, it makes it a bit easier. What about the stuff we don't support? As I mentioned, we've been working pretty hard to add stuff. And if it's something you need that isn't supported, please open a feature request. We'd like to add it. So there's a couple of different approaches we've got here. The first of these, we can provision ARM template within Terraform. So we have this Azure RM template deployment resource, which allows you to provision anything you want in ARM template. You can mix and match these too, so you can pass variables into an ARM template from Terraform and get variables, the output, sorry, of an ARM template into Terraform. So you can provision just the one thing that's not supported by Terraform as an example, and thread stuff through either way. Yeah, as I just said. Sorry. Yeah, I got like 3 more slides. Sorry. Yeah, the downside of this is Terraform can only deploy it. It can't detect drift or detect changes, the diff I showed you earlier in the plan, but it does help in some scenarios. So in this case, this is deploying an ARM template in line. One of the other things you can do is to define it from a file. So I just want to call out this file interpolation function. There's a few of these, but it just makes it more readable. It means you can split up your Terraform deployment and the ARM template. The other thing you can do is a provisioner. So this is this can run any command you want. So either you can SSH into a machine and run a command, or WinRM into a machine, or you can run this locally. So you can run the Azure CLI, PowerShell, etc. Again, Terraform can't perform any diffing through this method, but it works. And the syntax for that is like so. This is all on the Terraform website, so yeah. So just to summarize, Terraform's DSL, the HashiCorp configuration language, allows you to provision any infrastructure on any provider using a common language. Terraform plan shows you what it's going to do and ask you to confirm, Terraform's plan will show exactly what it's going to do, and then you can apply that with Terraform apply, which gives you confidence in like what it's actually going to do. When you're done, Terraform Destroy allows you to provision or to tear down those resources that Terraform has provisioned. And you can share those modules or share those configurations in a Terraform module, either within a Git repo or on a module registry or within the local file system. All that to say, thanks a lot. Cool. Just in the interest of time, I think we're going to move next door to the shift room if you have questions. But yeah, thanks.
Yeah, thanks, Tom. Just by coincidence, I started